So, we have finished chapter 1 and we are going to begin chapter 2 in this video, and we're going to talk more about the idea of atoms now to begin the chapter. So, if you want to read along, this is going to be chapter 2.1, and this is setting the stage, kind of starting to define what atomic theory is. What is an atom? And how do we consciously kind of build this idea of what an atom is and how it behaves, sort of. So, atoms, coming from the Greek word atomos, means indivisible, right? It's that smallest unit of an element that still has the properties of that element. And we're going to say first that all matter is made of atoms. Okay, matter is made of atoms, and then we have some postulates to this theory that I'm going to use figures to illustrate as well. So I'm going to fill in some words into this table. And this is Dalton's atomic theory, and it's something that you could look up as well if you wanted to read the specific postulates, but I'm going to put them here in this table. So the first one, we see all the blue balls. Each ball represents an atom. And this first one represents the fact that all atoms of an element are identical. So all atoms of the same element are identical to each other. Okay, all gold atoms are identical. There's no way to distinguish between one element and another if they're both gold. Okay, or if they're both hydrogen or both the same. Okay. The second one, if we move to the right, atoms can't be created or destroyed. We have the hammer here. Atoms cannot be created or destroyed. That also goes with the idea that matter can't be created or destroyed. Okay, can't be created or destroyed. If we move down to the left, this sort of goes along with the one right above it. We said all atoms of an element are identical. Atoms of different elements are different from each other. Okay. And what we're going to see is that will have to do with properties, but also masses. Okay. So they have balances here showing that both blue have the same mass and they're identical. The blue and the red have different masses. They're different from each other. So atoms of different elements are different from each other. Okay. All seems fairly simple at this point, right? And then the last box, the one if we move to the right again, compounds consist of atoms of two or more elements combined in small whole number ratios. This one's kind of long. Compounds, okay, consist of atoms of two or more elements. Okay, so that goes along with what we talked about with compounds earlier, right? They can be broken down into simpler substances. They can be broken down into elements. Well, compounds have the atoms of those two combined elements bonded together, and they're going to be combined in small whole number ratios. So no halves of atoms. Combined in small whole number ratios. Okay. So this is what we're building off of with atomic theory. And I'm going to move into talking more about the model of the atom. So we've talked about atoms a little bit, and to this extent we know this atomic theory, and we know that there's the smallest piece of an element. Well, let's look a little bit more at the atom. So the nuclear model of the atom, there have been a lot of models of the atom over the years and the centuries. Early, they just thought that it was some kind of constant composition throughout. But the model that we have now shows a nucleus at the center of the atom and empty space occupied by electrons. And I have a picture on the next page to show that. Okay. So, atoms are composed of three kinds of subatomic particles. So atoms do have building blocks, but those building blocks don't have the same properties as the element that they are, that atom is a part of. So atoms are composed of three kinds of subatomic particles, and this is going to be for all atoms. Okay. We have protons, neutrons, and electrons. Protons are positively charged. Okay. Sometimes you'll see them as a P with a superscript plus sign. Protons are positively charged. Neutrons are neutral. There's no charge, so there's a little zero, N with a zero superscript. And then electrons are negatively charged. And this will be a E with a little negative sign as a superscript, and that's the one that you will see me write out more often. We're going to look at electrons a lot later on, too. So we have these three kinds of subatomic particles. Two of these types are found only in the nucleus. So the nucleus is the very center of the atom. The nucleus is very, very dense. Okay. So most of the mass, this is the nucleus, most of the mass is in this nucleus. So the mass of the atom is found mostly in the nucleus, and then we have electrons that are around the outside. So the nucleus is the center point. The electrons will be somewhere out here, and they really kind of define the size. How far away the electrons are will define the size of the atom. So the volume of the atom is occupied by electrons. And kind of to wrap up this video, I wanted to show you guys this table. It summarizes what we said about the subatomic particles, and this is from a textbook. I don't believe that it is from our OpenStax text, but there is a similar table in that text. So we have the names listed. We have the symbol, right, this E minus, that's going to be the more important one. That's going to be the one that we use most often. And then it shows masses, and these masses are so small that it's really hard to interpret, but it's going to be grams. The main takeaway from these masses here, the values, are that the proton and neutron have pretty much the same mass, 1.67 times 10 to the negative 24 grams. Protons and neutrons have about the same mass. Okay, the electron has much, much less mass. Okay, electrons are much less massive. So electrons are by far the smallest of the particles. Protons and neutrons are about equal. And what they've done here is we're going to start looking at this type of unit too. This is a unit of mass, AMU. It's atomic mass units. And it shows, it's just a scale to help us understand such small masses a little bit better. We have proton and neutron about 1 AMU, and then the electron is quite a bit less than that. And then at the other end here we have charge units, and that just means the proton has a +1 charge, the neutron has a 0 charge, and the electron has a -1 charge. And so we're going to talk about that more as we dig into this further. And we're going to talk about AMU a little bit more too as we start to look at the periodic table. So this is where I'm going to wrap this video up. And then we're going to move into talking about elements and kind of what we're going to start to see with the periodic table, how we collect that information. So I will see you guys in the next video.